Okay, so yesterday we did a lot with chain rule, yes?
Yes.
Okay. Right there, I think at the very end of class, we kind of got to where we were doing chain rule within chain rule type thing.
Yeah.
I think that's what, back here on F, we did the chain rule like 2 or 3 times in a row. Up there, I guess that one was just one chain rule. But, so we've got to watch for not just chain rule, but other things happening with it and other things. So, as we look at H, f of x equals x squared times e to the negative 4 ln x.
Ooh, do we do product?
But not When you use the E rule that we used on the page before or something? The one? I don't know what.
So, okay.
That's my
And this is one where this is one I get caught by too, because I totally was going to take us a different direction. But, so I heard the word product rule. Words, product rule. Okay. Is this, the way it stands, technically a product rule?
Yes.
Yes. Because you would be doing, it would x squared times e to the negative 4 ln x, right? So it would be derivative of one times the other plus, and then reverse the situation. Now, there is a little bit of simplification, actually a lot of simplification, if you catch it. Look at that piece right there. E to the negative 4 ln x.
I don't know the natural log rules, so I don't know if I
Well, I
can
know
help.
that natural log base is E.
Okay,
Is that anything to do with that?
it does. Now, pause that thought though. Okay, hold on. The negative 4. That negative 4 is in front of the log. Where can I take it?
And to the exponent.
To the exponent. Yes, kind of the reverse of what we did here, yes? Okay, so with that in mind now, I've got to keep this x squared so I don't lose it. So x squared e to the ln x to the negative 4. Okay, so that's just the power rule of logs that allows us to take a power and move it out front as a coefficient, or the coefficient and put it up as a power. Now, Doug was pointing out, what is the base of natural log? E. So with that in mind, if the base of the power is the same and the log is in the base, we had a rule that when these bases are the same, well, it's not just the exponent in this case, it's equal to the insides of the log. What are the insides of the log?
X to the negative.
X to the negative 4th. So this essentially becomes x squared times x to the negative 4th. What is x squared times x to the negative 4th? X to the negative 2nd? Because 2 plus negative 4 is negative 2. So what we really have here is f of x is equal to x to the negative 2. So we're ready to do the derivative. What is the derivative of x to the negative 2?
Negative 2x.
Negative 2x to the negative 3. Better written, negative 2 over x to the 3rd. Okay. So that is just when you have an exponent here, a power, but when the log is in the exponent. If the base of this power and the base of the log match, it's equal to whatever is in the log. Okay. Let's look at I. G of x equals cosine squared of 4x minus sine squared of 4x. I don't know if you need it or not, but when it's cosine squared of 4x, realize that is cosine of 4x quantity squared, right? Minus sine of 4x, quantity squared.
I pull the 2's off front, or is that 2?
This isn't a log, so no. Okay?
Well.
That only works with logs. We have to take the derivative here.
So. Honestly, I would have done the same thing because like the derivative is taking the 2 in the front. So I.
Well, okay. And now we are going to take the derivative here. And what is the first step on taking the derivative? Put the 2 out front. Because what is the outermost function happening here? And that is something raised to the second power. How do we take the derivative of something raised to the second power? 2 out front. Cosine of 4x. Now raised to the power of 1 that I'm not going to write out. Now, that's the outside, right? Which was something raised to the power of 2.
Do we just stop at cosine?
I'm not sure. It depends on where your question's going because I just said, okay, we just did the outside.
Of the whole problem? Or just cosine?
I'm not to the second term yet.
Oh, okay.
We got to do this piece by piece or you're going to forget so much.
Okay.
We can't move on yet because we haven't used our chain rule.
Negative sine.
So something raised to the second is 2 times something raised to the first times the derivative of something. What's the derivative of cosine of something else? Derivative of cosine of something is negative sine of something. Notice, did I say something again? Does 4x have a derivative?
Oh. Yes.
Yeah. What's the derivative of 4x? 4.
Gosh.
And then you can stop there because we just took the last derivative we can. Okay. Now we do the next term. So we have something raised to the power of 2. So
2 sine 4x.
2 sine 4x, technically to the first now. Can you take the derivative of the inside?
Yep.
Yeah, what's the derivative of sine of something?
Cosine 4x.
Cosine of something. Notice we're keeping that 4x the same, right?
Times 4.
Times the derivative of 4x is 4. Okay? Clean up. Okay, on the first term. Do you see the 2, the 4, and the negative sign that can all go out front together? 2 and 4 and a negative is going to be negative 8 cosine 4x sine 4x. Good? Minus, on this next one, 2 and 4. So 8 sine 4x cosine 4x. Are they like terms? Yeah. It's cosine 4x, sine 4x, sine 4x, cosine 4x. It's the same thing as saying xy, yx. They're like terms. Negative 8 minus 8 is going to make this negative 16. Cosine 4x, sine 4x. Okay. J, x to the 4th sine squared x. Again, I don't know if you need this or not. As long as you know that sine squared, this sine raised to the power of 2, we're good. I just rewrote it as x to the 4th times sine x to the 2nd. What do we have to do here? Now we do have to do the product rule, right? I thought we were going to get the product rule up here on H, but we were able to do some simplification. Here we've got an x to the 4th and a sine squared x. There's no simplifying. So, product rule. if two pieces are multiplying, we're trying to take the derivative. Derivative of one of them. So derivative of the first. What's the derivative of x to the fourth? 4x cubed. Keeping sine squared x. Product rule says plus. And now we're going to reverse it. I'm going to keep x to the fourth. And what's the derivative of sine x to the second?
2 cosine.
Okay, let me ask that again. What is the derivative of something raised to the second?
2 something.
2 sine x to the first.
Yes.
So 2 times the something raised to the first. And then what do we know about sine x? It has a derivative. What's the derivative of sine x? Cosine x. So here we have a chain rule within a product rule.
This is a little confusing because I don't know when to use this. Like, how do you know when?
And that would not be multiplied by x.
Basically, anytime the inside is something other than x. If your inside is a function that is something other than x that can be taken the derivative of, you have to apply the chain rule.
Okay.
Technically, you can always apply the chain rule because if the inside is x, what's the derivative of x? Times 1. Okay, and then, you know, you get that constant, we can't do anything else, you know, because technically we could here say, okay, so something raised to the second was 2 times the something raised to the first. Times the derivative of something, derivative of sine x is cosine of something. So then technically if you want to, you could say, what's the derivative of x? What's the derivative of that inside? The derivative of x is 1. And so you know, you can always multiply by that constant of 1. Okay. Clean up. How did I leave this answer?
There's not much you can do.
I know, that's why I was looking at C. So, okay. Options. That first term, 4x cubed sine squared x, that's about as good as you're going to get. 4x cubed sine squared x plus. Now, on the second term, I would do a slight cleanup, and that is put the 2 out front and put this as 2x to the fourth sine x cosine x. That is one option my answer key has.
Can
Huh?
you take out a sign?
And
And x
And
cubed.
X.
And?
X cubed.
X
Jesus
cubed.
Christ. And a 2.
no, you can't take out Jesus Christ. Now you're taking it too far. Okay, so the other option is you can pull out a GCF. Okay, there is a 2. There is an x cubed. There is a sine x. Now, is this really going to make it a lot neater?
No.
Not really, no. Okay. When I factor the 2x cubed sine x out, I'm left with, on the first term,
2 sine x.
2 sine x
Oh gosh.
plus
X cosine
x
Yeah.
cosine x.
Oh.
Oh, wow.
Maybe Jesus shape.
Okay, so not really anything you can, I mean, here's the thing. Don't tune out the GCF idea. Okay, it can be helpful times. I know this time it's just, we're just taking the derivative and that does not look any cleaner. Just be aware there are times you need to be able to do that. You're doing a derivative on a multiple choice problem. We don't know how they're going to present the answer. So just always look for that GCF as a possibility depending on the situation. Okay. Ready for K? No, it's not ln x times ln x.
Oh, sorry. L and X though.
It makes a difference. Because if Mario's telling me that this is ln x time ln x, all I see is a basic product rule.
It's,
But since it's ln of ln x, that's not things multiplying. That's a function within a function.
Oh.
So it's a chain rule. It is gross. I agree.
Do you have a paper? This is kind of unrelated.
I'm sorry.
This is going back to my issues of log rules.
Hmm.
Do you have a paper with like log rules on it?
I might be able to find something.
Okay.
I thought we had one.
Yeah.
If nothing else, I can go back to Algebra 2 and pull out Algebra 2 notes, you know.
Have any
I've been
helpful?
over 2 papers, but I have
Yeah.
That would be because
Oh.
because you
struggle
didn't
with
do
logs.
fast.
Remind me to make a note later. Okay. We have,
You're right.
again, I'm glad we had the discussion of ln x times ln x versus ln of ln x. Because what this is natural log of x. So, outside function. Outside function is the natural log of something. What is the derivative of the natural log of something?
Whatever.
1 over something. Fair enough? So derivative of natural log of something is 1 over something, or 1 over the insides, and my insides are natural log of x. So it's 1 over natural log of x. Now, okay, so derivative of natural log of something is 1 over natural log of that. Derivative of natural log of something is 1 over something. Then you have to do times the derivative of
That's
something. What was something?
Natural log.
ln x. What's the derivative of ln x?
1 over
1 over the inside, which is x in this case. So 1 over x. Sorry, I started to get myself confused on that one. I don't normally get confused on these. So,
Why are we in fractions?
I'm sorry.
because that's the derivative rule.
Duh, Sophie.
The derivative of natural log of x is 1 over x.
Oh.
Is that what you need to see?
Yes.
Okay. I'm like, why wouldn't they be in fractions? That's the rule. I didn't know how else to explain it, okay? I'm like, of course they're in fractions. Sorry.
Sorry.
Visual good?
Yes.
I know, we're trying to remember all the rules. I get it. Okay, clean up.
I'm not an analyze this though.
1 over x ln x.
I'm not talking to you. I'm talking to Mario.
Okay. And here's the deal, guys. Do we see these crazy derivatives all the time?
no.
No. Okay. Well, we've got to get it's getting the basics. Here's what's the starter. Okay, F. Sine of e to the pi x.
Oh, that's right.
Okay, no. So what's your first question?
The derivative of something times something.
outside.
No.
Oh.
What?
What is my outside function?
Sine.
Sine. So what is the derivative of sine of something? Cosine of something. So we're keeping, and that when I say something, just we're keeping the inside the same, right? So derivative of sine of something is cosine of something. Now, if that something is anything other than x, we have to then ask, what's the derivative of that? So what's the derivative of e to some power?
E to some power.
E to some power.
And
Then,
pi, right?
what's the derivative of the insides? The inside being that some power. What's the derivative of pi x?
Pi. No, it
Pi.
Pi.
yeah. I said it.
Why would it be 1?
And that confused
Oh,
me.
wait.
It wouldn't be.
No, I
It
know.
was-
Because
I know, I haven't figured out why they were saying one either,
Yeah.
so.
I was
I
thinking because
didn't
added,
mean to say 1.
and that's not added, that's 1 point. Because if it
Okay.
was added, the derivative of pi would be 0.
Oh, 0 plus 1, but no. This is pi times x. So think of it like, what's the derivative of 5x? Derivative of 5x is 5, so what's the derivative of pi x? Pi. In terms of cleanup on this one, it's minimal. The only thing I can really do is put this in a different order. Yeah. And my different order would be putting the pi times e to the pi x times cosine of e to the pi x.
Looks so fun.
I know.
I sense a little sarcasm there.
Just looking at it, like 2 years ago, taking geometry and algebra 1, taking algebra 2.
Honest to God,
I would
just
4 cosine squared pi theta. If you need it, this is 4 times cosine. Sorry, I have an issue here where I'm not sure what I'm writing. Pi theta, and it's the cosine squared, right? So 4, that's just me taking that squared out if you need that visual. Okay, so what is the outside function?
Something being squared.
Something being squared. How do I do the derivative of something being squared?
You stick 2 out front
Eight.
and then
Okay, so it is going to be 2 times 4, which is going to be 8. I'll write that in a moment. Cosine of pi theta raised to what power?
First.
The first. Okay, so we did the derivative of something raised to the second. What's my inside that I'm doing?
Derivative
Cosine
of-
pi 0.
We have to do the derivative of cosine first. What's the derivative of cosine of something?
Negative.
Negative sine of something. So negative sine of pi theta. And then derivative of pi theta, which is pi. What would you have out front?
Negative 8 pi.
Do you see it?
Yeah.
There's a negative, there's a 2, and a 4, and a pi. So negative 8 pi cosine pi theta sine pi theta. At least I'm assuming I don't always check. Yeah.
Yeah, my stomach still hurts.
From the calculus or from the lunch?
Calculus. I had a good lunch and customers. But no cookies.
Tangent of square root of 2x minus 3. Now, you can think tangent of square root of 2x minus 3, or now, beware if I write this, tangent of 2x minus 3 to the
Shoot, that's what I should.
1/2. However, that 1/2 is only on 2x minus 3. Is it tangent to the 1/2? No. So just keep that straight.
So then which derivative for the outside would you do?
Okay, so what is the outside here?
The tangent.
It's tangent of something. The square root of 2x minus 3 is your inside. Okay? So what's the derivative of tangent of something?
Secant squared.
Secant squared. And I'm just going to write secant squared of square root of 2x minus 3. I'm not going to write the 1/2 business on that one. Personal choice.
Wait.
Secant squared. Sorry. We said it right. I just didn't write it right. Derivative of tangent of something is secant squared of something. Now, that something was a square root of 2x minus 3. How do I do the square root of something?
You have to change it into that form.
We're going to do the derivative of something raised to the 1/2, which means 1/2 moves out front times 2x minus 3 raised to the negative 1/2
Times 2.
times, is there something within that square root we can do the derivative of?
2.
We can do the derivative of 2x minus 3 being 2.
Your 2 and your 1/2 just cancel each other.
Yep.
Oh, crap. But there's a negative on
Okay, so I agree with what Doug said. The 1/2 times 2 can cancel. So then we have the secant squared of square root of 2x minus 3. And we have the 2x minus 3 to the negative 1/2. Negative tells us to take it to the denominator, and the 1/2 says it's a square root. So that's how I wrote mine. You guys are smart enough to realize that you could have written it other ways and still be perfectly fine. Try not to leave the negative exponents though.
The tables are making it.
I want to be done.
One page left. 3 problems.
3 pages down.
Okay. Let f be a continuous and differentiable function. Why do they have to tell me that? If they don't tell me it's continuous and differentiable, I don't know if I can do the derivative with this table. Okay, so there's a reason they're telling us that. On the interval from 0 to 1, let g of x be f of 4x. The table below gives values of f prime of x, the derivative of f of x. Find the value of g prime of 2/10.
Okay.
Amen.
All right.
Now,
Never back
You just
down
gotta
number what?
think about it.
okay, first of all,
Yeah.
we're going to do that in a moment. I'm not going to plug the 2/10 in quite yet. Okay? So I want us to just look at, given the fact that g of x is defined to be f of 4x, correct? So we're going to need to know g prime of x, correct? So let's work on just finding g prime of x. So, thoughts?
Well,
What's the derivative of f of something? F prime of something.
I'll work it.
And what's the catch here?
You gotta plug in your 1, 2.
No, not yet. I'm still taking my derivative.
Oh, you gotta times 4.
Chain rule
Mm-hmm.
times 4. Yes? This is the reason we did not plug the 2/10 in at the beginning. Okay? You have to figure out what this derivative is in just in terms of x before we plug in our x value. So are you with me there?
Mm-hmm.
Okay? Realizing that when you take the derivative of something and there is anything other than x in there, you have to do a chain rule multiplied by the derivative of 4x. Now we've taken the derivative. I'm willing to plug in the 0.2. Okay? So this means every place I see an x, I can replace it with 0.2. So f prime of 4 times 0.2 and times 4. I should have put that 4 out front, and I forgot that I was going to do that. So if I write my 4 out front, it's 4 times f prime of, what is 4 times 2/10? 8/10. So 4 times,
1.15.
according to the table, 1.125. And this is going to be g prime of 2/10. And it does work out to be 4.5. Big thing there is when you see derivatives and it's something other than x inside. Yeah, the derivative of f of x is just f prime of x, but don't forget that chain rule then. Okay, ready to try this next one?
Yeah.
Get a new table. Find the equation of the tangent line to x equals -1 if h of x is given as 3f of g of x. Okay, guys, equation of a tangent line. What do we need to do an equation of a tangent line?
Slope and
Okay, so you've got that so far. We need a slope and a point. Because based on the last test, I questioned that at points, if we knew we needed a slope and a point. Sometimes we knew it. Sometimes, I don't know if we knew it. Okay, in calculus, when I say we need a slope, what are your brains supposed to think?
Derivative.
We need a derivative, yes? So, and if we're trying to do this here, then in order to do the slope, we need to know h prime of -1. Now, I'm not going to put the negative at 1 in yet, though. We've got to figure out a derivative equation first. Make sense? So, if h of x is 3f g of x, h prime of x, and this is really just definition of the chain rule if you go back to the other day. The 3 is a constant, so it can just stay out front. What's the derivative of f of something? F prime of something. So 3 f prime of g of x. And then what do we need to say? Times g prime of x, the derivative of the inside. And then, yeah, and then this is just an x, so that's kind of where your chain rule ends. So. Okay, now we need to know the derivative at -1, because this is where we find the slope, right? It's the derivative at -1. So 3 f prime of g of -1 times g prime of -1. Three stays 3. F prime has to stay F prime for right now. What is g of -1? According to the chart, yes. So that's a -1 on the inside. Times what is g of -1? Didn't I just ask this question? Oh, g, there we go. I'm like, no, why am I so confused? Okay, I totally missed my own prime there. G prime of -1 is 2. Glad you guys are keeping me straight here. Now what? Now, 3 times f prime of -1, 4 times the 2 we already had.
24. I'm so proud of myself.
Oof, okay,
Multiplication.
so slope is 24. We also need a, we also need a
Point. Can't you just do x, like pick an x and an f of x? Because f of x is y.
You would use your h of x equation. And plug
Okay.
it into one.
we need to know when x is -1, what is h?
Oh, so it's like
So we're doing h of -1. So not h prime of -1, but this is going to be, our point is going to be from h of -1. So that means just using 3 f of g of -1.
6.
So 3 f, what's g of -1? -1. And then it's 3 times f of -1, which is -2. 3 times -2 is -6. So here we know that h of -1 equals -6. And that's the fancy calc speak for saying we have a point at -1, -6. I don't know that you will ever see calculus say -1, -6 if they're giving you a point. I don't know, you might on occasion, but more often than not, they're going to say h of -1 equals -6. Okay, what were we doing with all this information? Equation of a tangent line.
Wrong again. Mark.
Y equals
Oh, roll today.
24 x plus 1 minus 6.
Yep.
That was incredibly mean.
Okay.
I'm sorry that I hurt your feelings.
Folks, slope of a tangent, or equation of a tangent line, we've got to be able to do this. Okay? Gotcha. Okay, one last one. If j of x is defined to be f of g of x times cosine x, because why not? What is the value of j prime of 0? Again, I'm going to say don't plug the 0 in yet. We've got to find j prime of x. Oof. Okay. What things are we noticing here?
Like the beginning.
That's what I was waiting for someone to say. That's why I was kind of pausing and
Oh,
waiting.
the man.
Do you realize there's going to be a product rule in here?
Okay,
Now.
so I brought up a question. Do we do the product rule and then we do
The chain rule is going to be within the product rule. Is that where you're trying to go with this?
which one do you do first?
So right now the whole thing is a product.
So you have to do that one first.
So, well, the chain rule will happen within the product. It's not that the chain rule is later when we're done. It's when we get to that point and need it.
Okay.
Okay? So the product rule says I have one value times another value. So I have f of g of x times cosine x. So we're going to do derivative of f of g of x, keeping cosine x, plus keep f of g of x, derivative of cosine x.
Oh, okay.
Okay, so what is the derivative of f of g of x? F prime of g of x,
Times negative
times
g prime of x.
g prime of x.
Times cosine.
Okay, so I thought I did wrong.
Okay, first half, I'm pausing. Derivative of f prime, or derivative of f of g of x is the derivative of the outside, f prime of g of x, times derivative of the inside, g prime of x, keeping cosine x, so times cosine x, plus. Now this time through,
F of g of x.
we're going to keep f of g of x, we've already done the derivative of it, times the derivative of cosine x,
Negative sine x.
negative sine x. Are we clear? Clear as mud, maybe? I'm trying here. Okay, now, at this point, you can clean up if you want. There's only so much cleanup that can really happen here, though. Or just go ahead and plug in the 0. So. Oh, my goodness. J prime of 0. F prime of g of 0 times g prime of 0 times cosine of 0 plus f of g of 0 times negative sine of 0. Okay. Why can I not write a J? F prime of g of 0 means we start with g of 0. G of 0 is 2. So this is f prime of 2 times g prime of 0,
G
Negative 3.
negative 3. Times cosine of 0.
Sine of 0.
What's cosine of 0? 1. I know you guys, as I said, I've said this before, my cosine of 0 is just saying, oh, hey, it's right here at 1. I know you guys do the quadrants, but.
I feel like we always make it harder on ourselves.
Okay, plus f of g of 0. F of, what is g of 0?
4. Oh, wow.
2. Negative sine of 0.
0.
Yeah, because sine does, I messed that up, but sine does that, right? So that's 0. Okay, f prime of 2
-2.
times -3 times 1 plus, I don't really care, but what is f of 2?
3
And why do I say I don't really care?
times 0.
It's times 0.
Oh, shoot.
So,
Epnos must be
-2 times -3 times 1
6.
plus 0 if you want to get technical.
There.
I might have failed my test, but at least I got that problem right.
Me too.
Okay, guys,
Hold on.
you've got some time.
This is our chapter.
You've got some time. Use it.
We'll do. This is our time.
Now,
I'm shy.
you've got 35 questions. It's a lot, I know. Use it. Tomorrow we only have 2 pages of notes, so tomorrow I do plan to get through 3.2. And that homework then only has 3 pages of questions, which is 22 questions. So you'll have homework back to back 2 nights. Doesn't happen very often, but you will. Yes, dear.
I just need help.
Okay.
Number 7.
Yeah, number 7.